So good morning, ladies and gentlemen. This is Mr. Chen on Friday, March the 19th. And what we're going to do is a trig application found in section 5.8. With 5.8 trig application, they're supposed to be 3D word problems or 3D diagrams, and they're really tough. And I wish we had more time to actually go through some of the examples there. This one's actually pretty easy, even though conceptually it's hard because it's a 3D shape. And on your screen, if you're watching this video at home or you're watching it later this class, I'm drawing a three-dimensional object on a flat surface. So what you see, hopefully, in front of you, if you pinch the screen or look at it, it's a rectangular prism. Okay, it's a rectangular prism that has a length of 6.2, a width, well, technically this is the length 8.2, width of 6.2, and a height of 4.7 units. And the question is, can we find, first of all, find the length of that red line, this diagonal that's all the way in the front, and it goes all the way to the back of the shape. And then, of course, the second part is find theta, which again is the angle, and hopefully you guys can see it. It's the red side length, or red line, straight line, with the diagonal that's on the base. And if you want to pause the video and try this out, you can. But if you've taken physics with kinematics, some of you have already a good idea. And that's really what we're asking you to do. So some of you are already thinking about, well, with trig applications, what should you be doing? Well, you can use sine law, you can use cosine law, you can use SOHCAHTOA, you can use Pythagoras. And if you heard me say this, the shape is supposed to be a rectangular prism, rectangles. So the way that I like teaching this, and again, feel free to pause the video and try it yourself, but the way that I would do this particular question is break it into its two-dimensional components. So although we want to find the length of the red line, which is great, we first need maybe this dotted line. Again, that's on the base. So watch what I'm going to do. I'm going to reproduce the bottom rectangle like so. And it's not drawn very well. Let's draw that again. It's supposed to be longer. I didn't draw better. So this is the bottom rectangle. 6.2 is down here. 8.2 is right here. And that's our dotted line. Okay? And since it's a rectangle, there's a right angle there. So some are saying, well, why are you doing this? Because we can't find this red line directly. But I can find that dashed line. Anyone from the class actually can see it? Anyone have an idea? How could I find that little dashed line? You don't have to give me the answer. You don't actually have an idea. How could I find that long line? Abby?
Use Pythagoras.
Yeah, Pythagoras theorem is correct. See, 6.2 squared plus 8.2 squared is equal to, and let's just call this, I don't know, let's call this x. X squared. So let's do this quickly. 6.2 squared plus 8.2 squared is 105.68, so x squared is equal to 105.68. So x is equal to, take the square root of this answer, we get 10.28. It should be 10.3, but we're going to use it as a future calculation. So that's that length, 10.28. All right, does everyone see that? 10.28. Now, notice what I'm going to do next. I'm going to take that answer that our classmate Abby helped us out with and draw a new shape. That's our 10.28. I'm breaking this down. That's that diagonal that we're trying to find. And notice the height is this 4.7. And hey, look, we have another right angle triangle. And some students can't do this, and that's okay, because you're taking a 3D shape, but then you break it to its components. That's actually not that bad. And notice where the angle is. The angle we're trying to find is over here, between the red line and that dashed line. Again, I just reproduced it. But let's solve for this longer side. Any volunteer from the class maybe think of solving this red line? Put it harder. Any volunteer, an idea, strategy? Anybody? You don't have to give me the answer. Any volunteer, strategy? No. We're gonna use Pythagorean theorem again. So r squared is equal to 4.7 squared plus 10.28 squared. And again, hopefully I'm not off screen. Let's just do it really quickly. 4.7 squared plus 10.28 squared. You get 127. Sorry, squared is equal to 127.7684. Square both sides. Now ours equals 11.3. 0. So the length of the red line is 11.3 units. Right? We're just going to one decimal place. How can I find that angle? Now that we have this 11.30, notice we have a right angle triangle. Hey, we can use anything you want. I tend not to use this R because that was a calculator, so we'll use usually for this one. And I think everyone agrees the angle in yellow, which is what we want to find with the red line and that dashed line on the bottom, what angle that forms, we'll probably use tangent. Calculator, inverse tan, make sure I'm in degrees. 4.7 divided by 10.28. That angle, which is approximately to 1 decimal place, 24.56 degrees or 24.6 degrees, which is fine. So the big idea for this 3D problem, and I like doing this one as a short because even though we have sine law, cosine law, and SOHCAHTOA and cosecant, technically this one's actually easy because if you break it down to its components using Pythagoras and simple SOHCAHTOA stuff, we get the right answer. And that's for you, ladies and gentlemen. If you want to see other questions, there's a really good problem in section 5.8 on the Romeo and Juliet problem. There's also a boating question with bearings. And if you look at the examples, they're really, really good. Anyways, thank you so much for watching.